So in this video, we're going to talk about rational functions and quite extensively how to graph rational functions. And again, similar to all other graphs in the course, without having to plot a bunch of points. So to get started, we'll go ahead and define a rational function as p of x over q of x, where p and q both are polynomials. So p and q independently are polynomials. You put them together as a ratio, and you're looking at a rational function. We also have to make sure to be clear that q of x cannot equal 0. Being in the denominator, we can't have a 0 in the denominator. So to graph these rational functions, we're going to look at a four-step process, all of which, if you follow these steps, putting the graph together shouldn't be very difficult. So the first step in graphing rational functions is always to identify the domain. We're going to identify the domain every time in interval notation, and that one step will help us not only now in the beginning, but at the end as well, figure out where everything needs to be. The second step, which actually comes straight from the domain, is to identify the vertical asymptotes. Now, the vertical asymptotes are going to be vertical by their name, and they're going to occupy the space that we're not allowed to have graph. So in the domain, we say that we're allowed to have graphs some places, and where we're not allowed, now we're going to have these vertical asymptotes. The graph will never cross a vertical asymptote, and so once we establish those, we're ready to move on to the next step. The third step would be horizontal or oblique asymptotes. Sometimes oblique asymptotes will be called slant asymptotes, so if you hear me use either of the phrasing, they're just interchangeable. So horizontal or oblique asymptotes. Now, to decide which it's going to be and what it's going to be, we need to look at three different cases. So, case one. Now, if you remember from the definition, p and q are both polynomials. So polynomials have degrees, and we're going to compare the degree of the numerator with the degree of the denominator. So in case one, we're going to say that the degree of the numerator equals the degree of the denominator. So the degree of the numerator equals the degree of the denominator. If this is the case, then you have a horizontal asymptote at y equals the ratio of leading coefficients. We'll look at an example of that here in just a second. Case 2, for the horizontal or oblique asymptote, we'll say the degree of the numerator is less than the degree of the denominator. So you've got a higher degree on bottom. If this is true, then we have a horizontal asymptote at y equals 0 every single time. The third case, case 3, is where the degree of the numerator is bigger than the degree of the denominator. So the polynomial in the numerator has a higher degree than the polynomial in the denominator. If this is the case, in this course, we'll have an oblique asymptote, and I'll just say for now, to find it, we're going to divide. And we'll again look at an example here shortly. So those are the three cases for horizontal or oblique asymptotes. There is something else that we would need to do kind of as a maybe step 3A. The graph might actually cross a horizontal or oblique asymptote. So we would need to do a crossing check to see whether or not it does. All right. The fourth step before actually putting the graph together then would be to put together the intercepts. Most of the time, the two or more intercepts that you come up with will be sufficient in putting the graph together without having to need additional points. All right, so in the first example we're going to look at here, we'll just go through those 4 steps in order, and I think you'll see how it really is pretty easy to graph these if you have all the information in front of you. So first thing is the domain. Anytime you think domain, it's never a bad idea just to assume it's everything and then start looking for trouble. For us, the trouble would be the denominator. We have to make sure it's not equal to 0 under any circumstances. And you can see that at -1, we would have a denominator of 0. So we have to exclude that value from the domain. So in interval notation, the domain is -infinity to -1, union -1 to positive infinity. The second step, which again comes straight from the first, is the vertical asymptotes. Remember, these are going to occupy the space where you're not allowed to have graph. So we're not allowed to have graph from the domain we know at x equals -1. So the vertical asymptote would just be x equals -1. The graph won't cross a vertical asymptote, so we're ready to move on to step 3. You can see in step 3, we're looking for the horizontal or oblique asymptote. To determine that, we look at the degree of the numerator versus the degree of the denominator. Both are degree 1, which means that we have a horizontal asymptote at y equals the ratio of leading coefficients. So the leading coefficient in the numerator is 3, and the denominator is 1. So y equals 3 would be the horizontal asymptote. Now, as our next step, before we get to the intercepts, we're going to need to do a crossing check. So I'll come over here just off to the side, and we're going to determine if the graph f is going to cross the asymptote 3. So this is essentially us just finding a point of intersection, and we know from previous coursework that to find a point of intersection, we take the two curves and set them equal to one another. So I'll take my asymptote at 3, my function, and now we'll go ahead and we'll attempt to solve for x. So I'll multiply both sides by x plus 1. And if I subtract 3x from both sides, I end up with 3 equals a -1, which doesn't make sense. So therefore, it does not cross. So again, the crossing check is just looking for a point of intersection. We take the two things that we're wanting to see if they intersect. We set them equal to one another. In this case, it didn't make sense, so it does not cross. Okay, the fourth step would be the intercepts. So we'll need to look for x-intercepts and y-intercepts. To find a y-intercept, we let x be 0. If x is 0, you can see that our y would be -1. And if our y is 0, this is where we'd have 0 equals 3x minus 1 over x plus 1. When we multiply both sides by x plus 1, we get 0 equals 3x minus 1, or x equals a 1/3. So we've got all the information that we were searching for. So now I'm going to come over and put this graph together. Now, in putting it together, the first thing that I would suggest is to go ahead and put the asymptotes in. So we know that x equals -1 is an asymptote. We know that y equals 3 is an asymptote. And then we'll go ahead and throw our points in there as well. Our points, if we look carefully, we've got 1/3, 0, so maybe right here, and we have 0, -1, which is about right here. Now, this is where we have to have a bit of a discussion on just some logic. If you ignore the black axes and you focus on the red axes, you've got 4 different regions. You've got this one up here, this one, and this one. Now, we know because of the asymptotes that there's going to be graph in this region right here. So I can go ahead and connect those dots. Understanding how asymptotes work, we know that the graph is going to be come infinitely close as we get further out to the infinities and as we get closer to that -1. So we know that the asymptotes kind of act like magnets and kind of fence the graph in, if you will. Now, again, continuing our conversation, if I look up in this region here, you might be thinking to yourself, well, how do I know if there's going to be graph up here or not? Well, you know there's not going to be graph up here because if I were to put a graph in here, similar to how I drew the other one, it wouldn't be a function. And we know that it has to be a function. So there's not going to be anything up here. So now moving to the left of -1, we've got graph here or here potentially. It can't be both because if it did, it wouldn't be a function. And so I guess the question is, do we know if anything exists to the left of x equals -1? And we know that there is going to be something between to the left of -1 because our domain says so. Our domain says we have to have something between -infinity and -1, so there's got to be something either here or here. Now, which one is it? Well, remember, we found the intercepts. We found all of the x-intercepts. And if the graph was down below, notice how if it came through like this, it would cross the x-axis again, which it doesn't. So since we don't have another x-intercept, the graph has to be in this quadrant up here. Let's try that again. There we go. So there sits our graph. And we were able to put that together entirely by just looking at the domain, the asymptotes, the fact that it doesn't cross, and then the intercepts as well. From there, a little bit of logic allows us to put the pieces of the graph in the correct spot.